Okay, so you guys ready? Class.
Yes.
Okay, all right. So we're gonna go through, do our notes. My board hopefully is not gonna freak out too much because I don't want it to. Anyway, minimum, maximum, critical values. So these are important. So let's say we do one of those parabola problems. Let's go back to algebra. We have a parabola, right? An upside down parabola. So a real problem that I'm going to throw something off a bridge and I'm going to throw it up first. So what's going to happen there? It's going to go up, 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 right? And then it hits the max and then it goes down, right? Okay? So let's think about derivatives as we're talking about that. So as it's going up, the derivative, the slope is going to be, as it's going up, it's going to be, should be a positive slope, right? Should be a positive slope until it gets to the highest point. What's the slope at the highest point? 0. And then after that, as it starts falling, it becomes negative. So the derivative at 0 is going to be key for a lot of these things for minimum and maximum. So that is almost the majority of this whole lesson. There we go. Identify maximum, minimum values and local extreme values of a function. Let f be a function defined by the interval I if there is a number u in the interval for which fu is greater than equal to f of x for all x and I, then f has an absolute maximum at u. Did that make sense? Or everyone just looked at me and just said fu? See what I did there? Macho? Hey. Did you get that one? Okay, alright. Alright, so called the absolute, and the number fu is called absolute maximum value of f on I. So in the interval, well, I'm going to show you a little graph on this, so this will make sense here in a second. If there's a number v in I for f of v is less than or equal to f of x for all x and I, then that absolute minimum at v, the number fv, is the absolute minimum of the value. The values fu, fv, sometimes called absolute extrema or extreme values of f on I. Extrema is the plural of the Latin noun extremum. Extremum? Extremum. That thing. Okay, here's a graph of this. Identify absolute minimum of the values. Okay, I is the interval that I'm dealing with. In this interval, we have absolute maximum value. So u is going to be the value at the absolute maximum right here, right? That's what that means. So that's some value that's actually greater than all the other values on that. So when u is this, f of u is the maximum. For this one, v, this is actually going to be the absolute minimum value. So here, this is the lowest point of all my graph. So a lot of things that we do with this is actually going to be content of the question. So if we want to maximize profits, we want to minimize cost to make said profit for those. Local, okay. Let f be a function defined on some interval I, and let u and v be numbers in I that there is a open interval. That means parentheses on the ends. Parentheses on the ends, not brackets. Open interval has local maximum or relative maximum at u, and the number fu is called a local maximum value. Similarity, there's an open interval in I containing v so that f of v less than equal to f of x for all x in the open interval, then f has a local minimum or relative minimum at V, and the number V, f of V, is called the local minimum value. Term local extreme of value describes either local maximum value or local minimum value of that. So, here is the problem we're going to be looking at here. On this function right here, without my calculator tripping out on me, we have minimums and maximums because this thing is wavy. So in this one right here, since it's wavy, we could say this is not, so V is going to be a local minimum. It's not the total or the extreme of the entire problem, right? So because that would be a local. This one right here would be a local maximum here. It's a maximum for a segment of it, so it's not of the entirety of the thing. This one right here would be an absolute maximum on this one right here if we're talking about the entirety of the whole function. And right here, these ones right here are going to be open intervals, so parentheses. Can I include the endpoints if I have parentheses? Say no. No. If I have brackets, that means it's equal to. So I can include the endpoints on brackets because the definition for parentheses means not equal to. Not equal to the ends. Find the domain. Okay. So what would be the domain? Where's this one start? At 0. And it ends at 3 pi over 2. So what type of dots am I using? Closed dots, which is going to be bracket 0 to 3 pi over 2. Where's the function continuous? Over the interval from 0 to 3 pi over 2. So in between those things, it is continuous. And if you notice, it changed to parentheses instead of brackets because it has to be going from the left to the right. So we need something to the left of this. That's why it's not a bracket. Identify the absolute minimum and absolute maximum value and the absolute minimum value if they exist. Is there an absolute, let's start with max. What would be the absolute max? It would be 1, right? And where does that exist? When x equals 0. All right, what's the next one? Absolute maximum value, absolute minimum value. Okay, now minimum. So absolute minimum. Absolute minimum is going to be, I heard it? -1. And that when x is pi. All right, the domain. Identify local extreme values. So the domain for this is going to be from 0 to 3 pi over 2. And extreme values, do I have any extremes? Do I have any locals? Not in this one. most people try and say that right there, but it's not, because I'm not gonna include the endpoints. That's what I was talking about, endpoints there. So we have absolutes, not locals. Oh, for the next slide. Okay. So we got this one. Let's look at this one here. Now, what's the domain of this? We already did figure 10. What's the domain of figure 11? Parentheses. Not zero. 3, right? It's the x values. Okay. Mins, maxes. Identify absolute and local. All right. All right. So absolute min. Okay. Absolute min. When x is 2, absolute max is going to be 1. When x is 0, do I have any locals? Nope. Don't you hate it when just someone comes in and uses your fridge and doesn't even ask or tell you? Like it's like some common thing or something. Yeah. I just watched a guy go put stuff in my fridge. I'm like, what a douche.
Take it out.
Go sit it right there in the middle of the floor.
Yeah.
Really not that petty. I normally would be, but I'm not. I'm gonna use my fridge, just ask me to. Alright, what about this one? Let's start with domain. Parentheses. -1 to what? 4. And that's going to be? Bracket. Thank you. Alright, at -1. What does that line mean? Asymptote, right? Kiss my asymptote. Alright, do we have any absolute max? Nope. Absolute min? Absolute, I can include the endpoints. Local, I cannot. So since this one does have a bracket, my absolute minimum is going to be 1 when x is 4. And I don't have any locals. Not too bad? Okay. Do we need to go through each one of these? Hmm? 14? Okay. So the domain of this one is going to be so it starts at bracket, right? Bracket 0, 2, parentheses, union, bracket, 6, bracket, yes? Huh? It's the x values. Okay, that's good. So we got that. Now 14. Does it have an absolute max? Yeah. What's my absolute max? 6. Does it have an absolute min? Yes. What is it? -2. Does it have a local max? No, it doesn't. Because I'm not on local, I can't include the endpoints. Does it have a local min? Yes. It has a local min at 0. Is that straightforward? Yeah. So this one right here, is this one continuous? No. What about 15? Is 15 continuous? Not at 0, right? But it's equal at all values in that interval, but it is discontinuous. It looks like a piecewise, right? It could be a piecewise or absolute value with a, constraint right there where like, yeah. Function is continuous on a closed interval, a to b, then it has an absolute maximum, absolute minimum on a to b. A function f has a local min or max, or a local, at the number c, then either, right here, the derivative of f at c is equal to 0, or does not exist. If a differentiable function has a local maximum or a local minimum at c, then f prime of c is equal to 0. So there goes that problem again of me throwing stuff off a bridge. As it goes up, my slope is positive. When it reaches the maximum, the slope is going to be 0. And after that, then it starts going back down, and my slope is negative. Critical numbers of a function is the number c in the domain of the function in which that f prime of c is equal to 0 or does not exist. So, right here, we have critical number, it's equal to 0, equals 0. What is that one? What's that word on that one? That's a cusp. So is the derivative going to exist there? No, because you get a pointy point, and you can't get the derivative at a pointy point because there is a slope, and you're not going to get the slope on the edge of a knife. Same thing goes for here. And this is going to be the last one that we do today, and then we're going to pick it up. So finding the critical numbers of the following functions. So I'm going to go through and I'm going to do step by step for each part here so you could see. So this is going to give me f prime of x equals 3x squared minus 12x plus 9. And to find my critical numbers, I want it to be equal to what? 0. I want it to be 0. So 0 equals 3x squared minus 12x plus 9. I'm going to factor out a 3 minus 4x plus 3. This will factor. What multiplies to positive 3 but adds together to negative 4? Negative 1 and negative 4. Divide both sides by 3.
Wait. Negative 3.
Negative 3? Oh, negative 1, negative 3. Did I mess that one up? Or?
I messed that one up.
Oh, okay. There we go. Sorry. So, I don't know, focus on this part right here. So, divide both sides by 3. What is 3? I'm sorry, 0 divided by 3? 0. So this 3 is going to go away. So I could just look at this as 0 equals quantity of x minus 1 and x minus 3 using zero product rule. So anything times 0 is 0, right? So to make this true, to make this first part right here true, what would x have to be? If this becomes 0, the whole thing is 0, right? So zero product rule, x equals what? Positive 1, so x equals positive 1. Zero product rule here,
3.
x equals positive 3. Now, these right here are going to be my critical numbers. Do I know what they are? Do I know if they're mins or maxes or anything yet? Nope. They're just currently my critical numbers. Make sense? Okay. Alright, so I'm going to do B on another page because this one is going to be kind of complicated. So R of x is 1 over x minus 2. Now, looking at this one, I have a fraction, right? What can I not have in any fraction? 0 in the denominator. So that means it's going to be undefined, right? And if it's undefined, that's also a point that is going to be critical. So x cannot be what? Can't be 2, right? It can't be 2. So that is critical also. That's a critical number. Okay, so now we still got to do the derivative of this. So I'm going to rewrite this because I like chain instead. I don't like doing the quotient rule if I don't have to. R of x equal to quantity of x minus 2 raised to what power? Negative 1. There we go. So R prime of x is equal to negative 1 quantity of x minus 2 to the negative 2 times 1. We okay still? Alright, so critical means I set it equal to 0, right? So 0 equals, let's see, negative 1 over quantity of x minus 2 squared. So what do I get? Nothing. Why do I get nothing? If I'm going to clear out a fraction, what would I do to both sides of the equation here? Multiply by the denominator, right? Right? And what would happen over here on the left? I get 0. So is 0 equal to negative 1? So I don't have any places in which that this actually is going to exist. So, do I have critical points? Okay, how many critical points do I have? Just one at positive 2. Let's see.
So Pacho,
Yeah,
critical points don't apply to derivative if it's gonna be undefined.
if it's undefined, I can't take a derivative at that point. But I know because right here, it's going to be something like this. Or it's going to be the asymptote for this. It might just be a hole, like my graph's going to look like this, hole, or like that. So it's a hole specifically at a certain number. So this one would also be a critical point, right? Okay. So that's what it's referring to. Because we don't have any x's in which that the slope is equal to 0. So that means that if the slope is never equal to 0, that means it's always going up or it's always going down. It's never changing from a positive to a negative or negative to positive. Where are we at? X minus 2, 2/3 over x. G of x. Alright, this one, I kind of have to do the quotient on this one. So if I'm doing the quotient, I have f and g. So f is x minus 2, 2/3. F prime is going to give me a chain rule off of this, right? So chain rule, 2/3 quantity x minus 2. And I have to subtract 3 over 3, right? Subtract 2 over 3, that's going to give me a negative 1 over 3 times, what's the derivative of the inside? 1, right? Okay, good. And then next one is going to be my g is the x, g prime is 1. Alright, so f prime g. So quotient rule, f prime g. So it's going to be 2/3 x minus 2 negative 1/3 times f prime g, which is x. Wow, that's a horrible x. What happened there? X. Wow, it's just that spot in the board. Minus sign, because it is a quotient, it's minus sign. G prime, which is 1, times f, which is, come on, you can do it, x minus 2 to the 2/3, all over g squared. And this is going to give me my g prime of x. So I'm going to finagle this a little bit. So I'm going to rewrite it to make my algebra a little bit easier. So we want to set this equal to 0, right? Yes. So that's going to make the math a whole lot easier. 0 equals, I'm rewriting this as 2x over 3 quantity x minus 2 to the 1/3. I'm writing it with positive exponents here because this is going to help me out clear out my fractions. Minus this one over here, which is 1 over, oh wait, not 1. This one's not going to have that. 1 times, come on, x minus 2 to thirds over 1. And everything here is going to be over x squared. So I rewrote it like this to make that algebra a little bit easier. Can anyone identify something I could do real quick to clean it up a little? This is why 0 is my favorite number. Anything times 0 is? Alright, can I clear out the fraction, the first fraction? Multiply both sides by? X squared. If I multiply both sides by x squared, so over here it cancels, but over here it becomes 0. 0 equals 2x over 3x minus 2 1/3 minus x minus 2 to the 2/3 over 1. To be able to combine these together, what do I have to combine some together? Common denominator, right? So I'm going to multiply this second one over here times 3x minus 2 to the 1/3 over 3x minus 2 to the 1/3. And what's going to happen now because of that? I have a 2/3 and I have a times a 1/3. That's going to give me. What do I do with my exponents when I'm multiplying some together? I add them together, right? So 2/3 plus 1/3 is 1, or 3/3, right? So I'm going to have -3, because that's that one right there, and the negative in front, times x minus 2 to the 3/3, or just 1, and then 2x all over 3 quantity x minus 2 to the 1/3 equals 0. What's my favorite number? 0. Because it's going to clear out my fraction again, isn't it? Multiply both sides by the common denominator. And that's going to give me 0 equals 2x minus 3x plus 6. And that's going to give me x equals 6. So, at 6, what does that tell me? I have a critical number, okay? So I did all the math, and so I got an x equals 6. So that means that my derivative is going to be equal to 0 when x equals 6, right? There's one critical number. Now, there's another one in here. Can someone tell me where it's at? At 0, because when we set up the problem right here, any place in which I have a fraction, I cannot have a fraction with 0 in the denominator, right? So right here, I cannot have 0 in the denominator. So x cannot be 0. Is there any other places in which I have something in the denominator? How about right here? So that means x cannot be 2. So I have 3 critical points here. Alright, you guys, so the Screeching to Death actually says that our class is about over. Tomorrow we're going to pick it up, so pick up some homework questions and bring them up tomorrow. I changed the due date for the assignment to be today. Alright, make sure you guys like, share, and subscribe.